Alright, by special request, I am curving the laser along the curved ramp again, but this time I have the laser centered right in the middle. So here's my laser on a tripod, and there's my little ramp. It's cooled off tonight, so the bubbles all formed. Something different I've done this time is I have put little rings. They're just about the size of a finger ring, but they're probably stainless steel. They separate the platters on a laptop hard drive. That's where I took them out of. And I've put them spaced along so I can run the laser beam through all three rings. Let's turn off the overhead. Okay. So you can see the laser beam is running essentially concentric to the curved fiberglass roadside stake. And so here it is coming through the first ring. Let's see, actually I can show you an end view too. See, there they are going through the rings. So it goes through the first ring. The second ring. There it is, going not perfectly centered, but definitely through the ring. Interestingly, it's getting a little dispersed here. My gradient's not quite perfect, but you can still see most of the beam, even though it's as big as the ring, is going through the ring and out of the tank and hitting the automobile. So we'll look down from the top side. We can see that the laser beam is in fact, let's see here, I'm get it close but not so close my phone gets wet. There it is going through the last ring. Move forward towards the laser, passes 2x4. There it is going through the middle ring. And of course there it is going through the first ring. So I wonder if I can hold this up high enough. Probably not, but anyway, there is the laser beam, almost perfectly centered over the curved runway strip, whatever we want to call it. A friend asked me to do that specifically, so I thought I would just do it. Let's see if we can zoom in here. That'll... Okay, there it is going through the middle ring. And there it is glinting off the top part of the fire ring a little bit, because the beam's so wide by then. And I think we have the same scenario here. Let me just turn the overhead light on. Ooh, yeah. Okay. Basically, when we get right down... Oh yeah, so right about here it straightens out. See, it's curved, but when we get down to the gradient that it's going through, and actually when we get down low it actually looks concave, because the light is actually curving faster than, at a greater rate, a tighter rate than the bridge itself. But you can see we can look through that ring and see, well, is it going to let us focus? Oh, come on. It doesn't want to focus for me yet. Okay, I think that's the middle ring. My camera just doesn't want to focus. Yeah, that's the middle ring. And then the far ring is kind of squashed down, which is interesting because the beam spreading makes the beam the same height as the ring, which also means that from this perspective, the ring will appear squashed down to match the size of the beam. So that's kind of interesting. Alright. Alright, same setup as a few minutes ago, but this time I've increased the gradient a bit. So as you can see, let me just line up here. Get nice and square on there. As you can see, the laser curves more than the curved stake. Curved stake is still curved, and you can see it's, oh, let's fill over backwards here. You can see its rope is underneath here, and the rope is straight because it's super taut, and then the stake is curved still. I didn't touch anything in there. I just pumped in some more brine to raise the gradient level. So what I've done here now is the laser comes in right through the bottom of the first ring. So it's coming in low, right through the bottom of the first ring. But then it passes over the top, completely clears the middle ring, which is the same height as the other rings and the same height as it was for the test that I just showed you previously. Then it comes down and passes right through the bottom of this third ring as well, and then exits the fish tank and hits the car. And of course, from the top view, it is still essentially centered on the roadway here. So the reason I'm doing this is because one argument I frequently hear is that in order for us to see something over, say, the globe's curving water at a great distance, like a laser beam or anything, the claim is that that the light would have to be curving just exactly equal to Earth curve in order for that to happen. And what I'm showing you here is that the light could actually be curving anywhere between equal to and greater than. And what I'm showing here is the light is curving greater than the curved road stake, and it's still visible. We could still have the little laser guy right down there, 6 feet, 1 foot above the water, whatever. The laser beam could actually be arcing up and over 10, 20, 30 feet above the water, and then coming back down and hitting the observer 1 foot above the water. And without some observer in the middle actually measuring the height of the laser there, we really don't know whether that laser beam hugs the water 1 foot all along, or whether it's arcing a little bit above or even high above. So that's what I'm illustrating here. It does not have to... Well, this is going to get interesting. Let's see. See, we can see the laser beam going right over that center one, but because the refraction is greater than the road curve, the Earth curve here, the Earth itself appears concave, and the laser appears about straight when we get right to the same elevation. So let me turn on the overhead too here. There we go. So you can see down from observer level, that road actually appears concave. We can see the surface a long, long ways, all the way out actually. Everything we can see that everything, every bit of the surface is distorted, but it's visible. And this is what happens a lot of times when people shoot a laser over a lake and they think, well, we saw it, so it must be paralleling the lake. It could just as well be curving up and over. So there you go. Let me shut out the overhead and just look at this a little more. Right through the bottom of the first ring. Right over the top of the middle ring. And then right through the bottom. I bumped the tank a little, so now I got it sloshing, but anyway, interesting. Alright. Now I am gonna, you know what? I am gonna drain that brine out, straighten that beam out, and then show that it's not possible to get it through the centers of all three rings, I think. Let's see here. To do that, I need to unplug the pump. Turn on the drain valve here. To drain the brine back into the brine tank. So that way I can reclaim some of my brine. See, it's going to be, yep, you can see it. It's coming right out of there. And this should actually have a pretty quick effect on this laser. So I'm just going to film it here for a bit, see what we get. Yep, see, it's straightening out that laser beam. Because the brine's dropping and it's moving the whole thing into a much less gradiented, a much more gentle gradient. Well, this is getting boring. I'll stop this and then restart it once I have the gradient down. Alright, welcome back. And I have now drained out enough of the salt water that the laser beam is going through essentially fresh water. So you can see now the laser beam is pretty straight. And sufficiently straight to demonstrate what I have in mind here. So, what I've got here now is I've got the laser beam going right inside the first ring, but just under the top, just squeezing under the top. If I go any higher, then in fact it's starting to hit that ring. So if I go any higher, that ring will block it off. So I've got it going through the ring, but right at the very top. Now, the middle ring, I have it going right at the very bottom. In fact, you can see it's actually hitting the bottom a bit. So it's going through the very bottom of the ring. So I am doing my best to get this laser beam to go through all three rings without the aid of the refraction bending the light. So it's going through the top of the first ring, to the bottom of the second ring, which makes it at the lowest possible angle to try to go through the third ring. But as you can see, it shoots cleanly over the top of the third ring and leaves the tank and hits the automobile. So what this is showing is that the geometry of these three rings, with a straight line ray, it is impossible to get a straight line ray to go through all three of these rings if it's straight. So this shows that it does require ray bending in order for the ray to have gone through all three of those rings. So there you go, and I think that is a wrap for this video. Hope you enjoyed it.